So we've studied how to factor trinomials. Now, trinomials are probably the most common kind of polynomial that you'll need to be able to factor. So understanding how to factor trinomials, that's an important step towards mastering factoring. But it's not the end of the story, because the next most common type of polynomial that you'll need to be able to factor are what are called binomials. Bi, like bicycle. Bicycle has two wheels, so binomial has two terms. So here's an example of a binomial, 4x squared minus 25. The two terms are 4x squared and negative 25. Two terms, binomial. Now, the good news about binomials is that we can actually turn them into trinomials. We can make them special cases of trinomials, so we can factor them using the same box method that I showed you for trinomials. And that's the good news. So we don't have to learn a whole new, brand new method. Now, you'll notice that in this binomial, which is going to be the case with a lot of these binomials, it's missing one of the terms that would make it a trinomial. You got the x squared term and you got the constant, but we're missing the x term, which is what you normally have when you have a trinomial. And like I said, that's usually the case. It's often the case when you have a binomial that you need to factor. It's going to be missing usually the x term. So in order to make this easier for ourselves, what we're going to do is we're going to put that x term back in, but with a 0. So we're going to do it like this. So what I did is I put in the missing x term, but I put it in with a 0 coefficient. Okay, and that's because it's missing the term 0 times anything is 0. So it doesn't really matter that I have this here. It doesn't change the value of the polynomial. It just makes it into one that we know how to factor already, which is a trinomial. So we're going to consider this problem, 4x squared plus 0x minus 25. And now let's go ahead and factor that using our trinomial techniques, the box method. So you guys are old hat at this already, so you know what's coming next is I'm going to draw my box. Okay, so here's my box. I know it's going to factor into two binomials, so I divide the box in two sections. Okay, so let's do the setup. So first term, highest degree term is 4x squared. So that goes in the upper left. Constant term, negative 25. That goes in the lower right. In order to figure out how to split up the middle term, which now is a 0x, we're going to have to do a diamond problem on the side here. So let's set up this diamond problem. So at the top of the diamond, we're going to have, ignoring the x's, first coefficient times constant term, first times last. 4 times negative 25 is negative 100. So that goes on the top. Then I take the middle coefficient, leave off the x, just the coefficient, which is 0. That goes on the bottom. Okay, so I want you to figure out this diamond problem. If you need to, pause the video, go off and think about it, and then come back only when you know the answer. Okay, because you need to be able to do these without having to think too hard. Okay, so you have the answer. So it must be negative 10 and positive 10. Negative 10 times 10 is a negative 100. Negative 10 plus 10 is 0. We've seen these kinds before where you have the same value but opposite sign. Okay, so that tells us how to fill in the other two boxes. Doesn't matter where the negative and the positive go, so I'm going to put the 10x here and negative 10x here. When I put them back in, since these two numbers tell us how to split up the middle, which is 0x, and the middle term has an x with it, then when I put them back in, I put them back in with the x's also. Okay, so now it's just a matter of GCF. So going across the top row from right to left, 10x and 4x squared, GCF is a 2x. Bottom row, 25 and 10x, GCF is a 5. Oh, we have our negative row. So remember, if the box next to the edge where you pull out the GCF has a negative in it, which this one does, negative 10x, we put the GCF as a negative. Now we go up the columns from bottom to top. So first column, negative 10x and 4x squared. GCF is 2x. I keep that on positive because remember, it's only the box next to the edge that determines the sign. And then second column, negative 25 and 10x, GCF is a 5. Again, the box next to the edge is closest to the edge is a positive, so the GCF is positive. Okay, so here are our two factors. I got 2x plus 5 and 2x minus 5. So my factorization is 2x plus 5 and 2x minus 5. Okay, so this is when you have a binomial, this is how you can do it. You can turn it into a trinomial, just put in the missing x term with a 0 coefficient, and then you just carry on the box model as you normally would. Okay, now, once you start to do a few of these, you may start to notice there's a pattern with these that you can sometimes use as a shortcut. So notice, like in this problem, 4x squared, that's actually a perfect square. A perfect square is a number that you can break down into two equal factors that when you multiply them gives you that number. Like 25 is a perfect square. 5 times 5 is 25. 4x squared is a perfect square. 2x times 2x. So you might notice there's a pattern in these binomials. When you have two perfect squares that are subtracted, like this one is subtracted, we sometimes call that a difference of squares. You may hear that term coming up, a difference of squares. When it's a difference of squares, you notice this pattern, how it factors. 2x plus 5 and 2x minus 5. They're exactly the same factors, but one's a minus, one's a plus. Okay, and the terms that make up each factor are the square roots of what these terms are. So 4x squared is 2x times 2x. And so the factor, first term in the factor is a 2x. And then 25 is 5 times 5. The second factor in each, or the second term in each factor is a 5. One's a plus, one's a minus. Okay, now, if you don't quite understand or see where that pattern comes from, don't worry about it. You can always do it by just putting in the missing x term as a 0 and just doing your box model. Okay, but for those of you who like to see patterns, there's a pattern for you to take a look at, this so-called difference of squares. Okay, so this is factoring binomials.